Hey, recently the news were published about this AlphaCode system, which is writing code and even winning the competition among other programmers. And about 6 months ago, another news was published about Codex system, which was made by OpenAI, and it was also writing code. The video that they made actually demonstrated the ability to write even a software system in JavaScript, which is sort of a game or something quite primitive, but still it's a software which was written by the machine, which was expecting us people typing in some requirements in a plain English, and then the code was produced in return. And I even got an early access last summer to this Codex system, and I played a little bit with it, so I can tell how it works more or less as an end user. But more interesting is what was published just recently, this the AlphaCode system. They published a paper which explains how the system works and how it wins the competition, and I decided to record this video to explain how it works and to explain why I think this is not really, in my opinion, the right direction of research in the area of artificial intelligence in relation to writing code. I think it's a wrong direction. So let me explain my point, but first let me explain you how it works technically, how I understand it works, because I haven't seen the inside, but according to what I've seen in the paper, here it is. First, they get tons of source code from open public GitHub repositories, like millions and millions of billions of lines of code. Then they break those lines of code into tokens, tokenize the source code, and they feed those tokens to the machine, to the model. They call it model in machine learning. So the model is basically like a black box. The behaviors of this black box is not predictable, but you can feed the data in form of vectors of numbers, and the machine will understand that some numbers stay closer to each other more often, and some numbers are much further away from each other more, or like time to time. So the machine will understand internally, will remember that, for example, if there is an if in the code, then there's going to be then somewhere and then else somewhere. So if, then, else, these tokens, they will be seen close to each other, closer than, for example, begin and end or something like this. This model will create sort of neural connections or links. I don't know, maybe I'm not using the word neural correctly, but there will be many internal connections and knowledge about which tokens stay closer to each other. It will not understand what these tokens mean, but it will know that they stay, the frequency of usage them next to each other is certain in some cases. Then they take existing tasks which were given to programmers before in order to run the competition, the descriptions of the task in plain English, and the results produced by programmers in, let's say, Java. This is the next data set. The first data set was just a huge amount of lines of code. Let's forget about that. The next data set is the English text versus some small piece of code written in a response to this English text as a solution to the programming task. So the English text is pretty big. It's like 5-6 paragraphs of text explaining what needs to be done, and then the solution in Java, let's say 20 or maybe 50 lines of code. And then they also tokenize this and this. So they turn the English text into numbers, so each word or each character even becomes a number, and then this text again into the same tokens we've seen in the dataset 1. Then they feed this stuff to the model, training the model, it's called training, so that the model associate now not only token to token, but also English words to the tokens seen there. And this they call fine-tuning, because this dataset is much smaller than the previous one, and they don't have so many tasks, they don't have so many task descriptions, maybe hundreds or something like that. So they feed it to the machine, and somehow, as far as I understand, they tell the machine that these connections are much more important than the connections the machine have seen before in the previous data set. So the machine gets some knowledge, some extra knowledge about English text versus the code in the solutions. And then the final step, they take a real programming task, not the final step, the next step. They take the real programming task in English. It's a new one, new description of the task. They don't know the solution, but they know the description of the solution, the expected input, the expected output. So in the input, the Codeforce website, Codeforce, they explain what is supposed to be the input for the solution you provide and what we expect as an output. So they take these two parts and they, as far as I understand, they didn't say it in the paper, but I understand it, that they create sort of a unit test. They write the unit test manually, seeing the input and seeing the output. So they have the English text, they have input, they have output, they don't have the solution. And then they tokenize this English text, give it to the model, and the model generates, just going through the English text, not understanding what the text is about, but generates token by token the piece of code, which looks like, which is Java code, of course, and which is very close to one of the solutions they trained the model with. Remember this, the solutions from the data set number 2. So it will look close, but with certain variances. It's not will be exactly the same, but it will vary here and there because the model knows way more than this existing solution. So the code will look a bit different, or much different. I don't think much, but a bit different from one of these solutions they train the model with from the data set number 2. So they get this the piece of code, and they ask the model to generate many of those pieces of code with different variances. So try again. The model generates millions of solutions. So the model tries to vary tokens here and there and generates many possible solutions, which somehow, we don't know how, nobody knows how, somehow is relevant to the English text they gave as an input. So we have a million of solutions to the problem. Now we need to find one. So what they do, they feed those, let's say, million solutions, million pieces of Java code, million pieces of script. They use probably Python, not Java code, but not Java, but Python. A million scripts in Python. One of those scripts may be the solution for the problem. So they run a number of virtual machines or whatever. They have a huge amount of resources, hardware resources. It's a Google, remember. So they run these 1 million scripts on a million of, let's say, a million of virtual machines or something. And one of those scripts, or maybe a few of those scripts, will actually compile and will actually pass the unit test they created. So if you give the input to it, it will generate the output expected by the unit test. So they throw away 99.999% of examples out, and with a few examples left, they have a number of them. And then they take those examples which are left, and they give these examples to the Codeforce's website and say, I found the solution. The Codeforces, they have the real unit test, not the artificially created unit test which expects this input and this output, but the real one. So the Codeforces tries to run this code through the unit test, and of course it fails in some cases. And according to their statistics, it fails in 70% of cases. But in 30% of cases, it matches, and Codeforces says, yes, you managed to create the product, the solution, you managed to solve the problem, we accept your results. This is how technically it works. So in order for this to work, you need a huge number of machines, a huge number of resources to actually try all the garbage your machine produces and to see which one actually works, which one actually compiles. So why I think it's a wrong direction of research? I think it's not only it's funny, because in my opinion it's funny, it's not artificial intelligence. They're not making the machine think. The machine doesn't understand requirements. The machine doesn't know what's coming in. The machine doesn't make it, for machine it's not there is no difference whether it's a English text that describes the task, or it's a recipe of a soup, or it's a Shakespeare's poem. The machine will anyway generate some code. So if you feed the machine with the description of a task, or you give a soup recipe, some Python code will be in the result, will be produced. In my opinion, that's the indicator of whether it's an artificial intelligence, or just a random number generator. So the intelligence will not understand that the input is completely unsuitable for actually even trying to think about it. So the proper intelligence, no matter artificial or real intelligence, would say it's a soup recipe. You cannot fool me like this. I'm not going to generate code from the recipe. I'm expecting the description of the task. This machine will not tell the difference. It's like training the parrot to say a few phrases and then tell that parrot actually has an intelligence. That parrot actually understands when he or she says, I love you, then the parrot understands that this is love and this is you. The parrot doesn't understand that. It's just a combination of sounds for the bird. It just generates the sound. That's all. There is no semantic inside it. The bird doesn't know what is being said. The bird just listens to the reactions to requests we provide to the bird and generates the output as a sound. Exactly the same this machine does. And there is only us who believes that the bird has intelligence. In reality, there is no intelligence, no semantic in the code. Even if Google and this the company DeepMind, they go in this direction, continue doing the research and continue increasing the amount of resources they have, it's a dead end in my opinion. In reality, in real world, we're not solving programming tasks. We are writing code which is supposed to be maintainable and supposed to work much longer than the lifetime of a programming competition. So what they do, they just find a solution which will pass one cycle of validation on the competition platform. So they just try to find what will fit. They are not writing the code which will be maintainable and properly written. It's a garbage code by definition. It's a garbage code and it will never be good code because there will be no information about the semantic of the code. Let me finish this. So if they would go a different direction, if they would pay attention to the AST, like abstract syntax tree details of the source code, and if they would somehow understand the elements of this AST tree, or maybe somehow find suitable pieces, but even in this way, I don't think it's possible to go that direction. To summarize, I think it's just technically not possible with machine learning. With machine learning, which is right now called artificial intelligence. So machine learning is not the tool for generating information, for creativity. Machine learning is a matching tool. It's just more powerful statistics, just more powerful tool for statistics. It just much faster finds you the fingerprint and the huge databases of fingerprints. Just a faster tool. But for finding, for matching, not for generating. They are trying to tell us that they are generating something, that they invented artificial creativity. They didn't. There is no creativity. It's just a fast finding of the right match for the competition. If they continue going this way, they're just leading us towards the wrong direction. It's a dead end of research. That's what I believe. I think that current artificial intelligence, machine learning can be much better used for automated refactoring of the code, for auto-completion, for many other tasks, but not for writing, not for generating code. This will never work, in my opinion, with machine learning. If we invent something else, not machine learning, but some other mechanisms of artificial intelligence, maybe, yes, the machine will write code, but not the way they do it now. Thanks for listening. Stay tuned. Bye-bye.